Okay, quick video for today because I couldn't record this in class. So basically, I am starting off with trig, and SOHCAHTOA will help you to remember that sine is opposite over hypotenuse, and cosine, ka for SOHCAHTOA, adjacent over hypotenuse. And tangent is TOA, opposite over adjacent. So when does that matter? Well, imagine for a moment you have a triangle, and let's say it's a 3, 4, 5 triangle, and I don't know this angle. We call that angle theta. Theta is the variable we use for that. It's just a Greek letter. And if I wanted to do the sine of this angle, and then I would do the opposite over the hypotenuse. The opposite one from this is this, and the hypotenuse is this. And so sine of theta is 3 over 5. Cosine of theta then is this one, adjacent over hypotenuse. And you need to have those memorized. And SOHCAHTOA does help. SOHCAHTOA. All right. So cosine of that angle, cosine is adjacent over hypotenuse. This one's the adjacent side. Adjacent means like right next door, versus opposite would mean like across the street. All right, so cosine is adjacent over hypotenuse, 4 over 5. And tangent of that angle, then, TOA, opposite over adjacent. This one's the opposite one, and this one's the adjacent one, so 3 over 4. All right, now, what if you actually wanted one of those angles? Like, I want this angle. How do I find out what that angle is? I would take this sine equation and do inverse sine on both sides. And inverse sine and sine cancel each other out, so then it's down to just theta. And theta equals inverse sine of 3/5. So I'd put this in a calculator, inverse sine of 3/5, and I'd put the 3/5 in a parentheses so that you don't, anytime you're putting something in the graphing calculator that's a fraction, you really should put parentheses around it. That keeps you from by accident doing sine of 3, or say inverse sine of 3, and then dividing it by 5. You want the inverse sine of 3/5. So if I take my calculator and I go to inverse sine, which is right above sine on the calculator, and I go inverse sine of 3/5 in parentheses, I hit enter, I get 36.86, about 36.9 degrees. And that's theta. So what did I do again? I did inverse sine to undo sine, and then I have theta equaled that, and inverse sine of 3/5, inverse sine of 3/5 here, came out to about 36.9 degrees. Now, if you got something completely different than that, you're probably in radian mode on your calculator. Okay, the next thing I taught was about these special right triangles. This one's called the 45-45-90 triangle, and this one's the 30-60-90 triangle. And on this triangle, you have sides of 1, 1, and the square root of 2. You need to memorize that, absolutely. We're going to do that about 50 times this year. And this one is 1, 2, and the square root of 3. All right, so now, if I wanted to take this and this, I can now do a lot of problems using those special right triangles. Like, for instance, this one. So if I was going to attack this problem, I would immediately bring down the classic right triangle. And I think it's a really good tip to make the triangle in the same orientation. You know, the really pointy end is going down here, so I make the pointy end go down. And I put them side by side like this. And then I say this must be a 30, 60, 90 as well. And that side ratios right here that I have for my memorized triangle would be 1, 2, and the square root of 3. Now, I think one of the best ways to do this would be to set up an equation. This is the hypotenuse, right? So to find that side, I'm going to call that side h. You start with the h and you say h is to 2 like, and then what two other sides do I have? Oh, the 10 and the 1. So I said h is to 2 like 10 is to 1. And when you have an equation like that, it's so easy to solve it. you don't have to cross multiply. You just have to say, I gotta get h alone, so I'm gonna multiply both sides by 2. That'll clear my denominator. You wanna clear fractions whenever you can. Okay, so that's gone, and I have h equals 20. And some kids would say, but I could do that in my head. I knew that this side is supposed to be twice as big as that side, so 10 doubled makes 20. Yep, that's a way to do it too. But that way won't work nearly as well for figuring out this side. So let's say I wanted to say this side is called B. Could call it Q, I could call it anything, but I'm choosing to call it B. Well then, I would go B is to what? B is to the square root of 3 as 10 is to 1. So then I'd multiply by the square root of 3 on both sides, and I get B is 10 square roots of 3. Okay, so if you had to do this one, I hope your first thought would be, you said to make another triangle in the same orientation. That's one of the specials. And the special triangle is the 45, 45, 90, and that's the 1, 1, square root of 2 triangle. So now I'm going to go, what's the variable? What's the thing I want to know? I'm going to start with h for hypotenuse, and I go h is 2 root 2 as, I hope you know, 11 root 2 is to 1. Multiply both sides by the square root of 2. And I now have h equals that, which is square root of 2 times square root of 2 is square root of 4. That's really 2. 2 times the 11, 22. Okay, so that's the basics. Now, I'm going to give you an example of a question. So let's say they give you a triangle like this, and they say, this side here is 4.6. This side here, I don't know. And on this side's an h for hypotenuse. And this is not a special one. Let's say this is not a 30, 60, 90. I just showed you how to do that kind. What if this is unknown, but this side here is 5.6, and I don't know how long h is. Well, I could do a squared plus b squared equals c squared to do that. That'd be pretty easy. But what if I don't care about that? What if I care about this angle right here? All right, well, I go sine of that angle is opposite over hypotenuse, which would be 4.6 over h. That doesn't really help me. You know why? Because I got too many variables. Sorry, 4.6 over h. So maybe I shouldn't do sine. Which one should I do? Sine, cosine, or tangent? Well, I have the opposite and the adjacent. So I should do the tangent of theta. And the tangent of theta, TOA, is the opposite over the adjacent. It's 4.6 over 5.6. And how does that help? Because now I can do inverse tan. If you do inverse tan on both sides, you'll get the tangent off of here, because inverse tan cancels tangent. And inverse tan of 4.5 over 5.6, sorry, 4.6 over 5.6. You type that into the calculator and you can get your final answer. And the inverse tangent of that is 39.4. So what did I figure out? I figured out that my angle there, this angle, theta, would be 39.4 degrees. Okay, there's your brief lesson for today. And there'll be a lot more coming tomorrow about trig.